This video is an introduction to oxidation and reduction reactions. We often abbreviate oxidation and reduction, so we just call these redox reactions for short. So, what is an oxidation reduction or redox reaction? Here's a quick definition. In oxidation reduction reactions, electrons move between atoms. Check out this diagram here. We got atom A and atom B, and there's an electron moving out of atom A into atom B. So this is definitely an oxidation reduction reaction because there's an electron moving between the atoms. Now, we can describe the movement of this electron using the words oxidation and reduction. So let's learn specifically what both of these mean. Reduction is a gain of electrons. I know this seems kind of confusing because usually when you have a reduction of something, you have less of it. We'll talk later about why a gain of electrons is called a reduction. But anyway, reduction, gain of electrons, and then oxidation, which is a loss of electrons. So, we got reduction and oxidation. What's happening to atoms A and B over here? Well, atom A is giving up one of its electrons. It's losing an electron. So at atom A, oxidation is taking place. Atom B is receiving an electron, it's gaining an electron, so at atom B, reduction is taking place. Now, we can modify these words slightly to come up with terms we use to describe what's happening to the atoms. Atom A is undergoing oxidation, so we can say that atom A is being oxidized. Atom B is undergoing reduction, so we can say that atom B is being reduced. So we got oxidation, oxidized, reduction, reduced. The big picture here is that reduction is a gain of electrons and oxidation is a loss. So I don't know about you, but when I was first learning this stuff, I found it so confusing. Why should a reduction be a gain of electrons? Usually when you're reducing something, you're getting less of it. So here's one thing that might be helpful to think about. That's that electrons have negative charge. So as you add electrons to something, its charge goes down. The more electrons you add, the lower the charge. So as you add electrons, as electrons are gained, the charge reduces. So that might be helpful to keep in mind to have this make a little bit more sense. Still, these things can be really confusing to remember. So here are a couple really great mnemonics. First is the term oil rig. This is the name of one of those big structures you use to drill for oil. OIL stands for oxidation is loss, and RIG stands for reduction is gains. This is a really good mnemonic. Here's another one you might like if you like animals. Leo the lion says grr. All right? LEO stands for loss of electrons is oxidation, and grr stands for gain of electrons is reduction. So learn one or both of these. They'll be a great way that you can always remember what reduction is and what oxidation is. Okay, oxidation and reduction happen in all sorts of chemical reactions. They're like the super important thing that makes those reactions happen, that makes them go. So to learn more about this stuff, we're going to have to look at an example of a chemical reaction where oxidation and reduction are taking place. Here's a chemical reaction that we're going to be talking about. Sodium and chlorine coming together to make sodium chloride, table salt. Now, sodium chloride is an ionic compound, which means that it's made of ions. Specifically, the sodium 1+ and the chloride 1- ions. These two ions stick together because they have opposite charges, and opposite charges attract. Now, Na and Cl, they didn't always have charges, though. Over here, before they combined, they have no charge. They are two electrically neutral atoms. So in order to come together and make sodium chloride, these two atoms have to end up getting charges, and then they stick together. So let's talk about how this happens, how they end up getting charges. So we start out with Na and Cl here as electrically neutral atoms with no charge, and they're on their own. They're separate. The next thing that happens is sodium gives one of its electrons to chlorine. So this is where the charges come in. Sodium loses one of its electrons, so it becomes Na plus 1. And chlorine gains an electron, so it becomes Cl minus 1. Now we have two ions with opposite charges. What do oppositely charged things do? They stick together. So these two ions come together and they stick, making sodium chloride. Okay, so this is the process where we start from electrically neutral atoms. We have an electron transfer, we get ions that then stick together. So here's the equation that I showed you earlier that describes this process. There are a couple things that I could add to this, though, to make stuff a little clearer. Check out these numbers that I've written in here in the red. These are called oxidation numbers, and they give me a sense of what's happening with the electrons and with the charges. So above Na and Cl, I've written zeros. That indicates that these two atoms start out being electrically neutral. They have no charge. That's what the zero means. Then on this side of the equation, once the sodium and chloride have taken on charges, I put those charges above each element. Plus 1 for the sodium and minus 1 for the chloride. These oxidation numbers help us keep track of how charges change during a reaction. Most importantly for this reaction, they remind us that sodium and chlorine start out neutral and only end up getting a charge later after this electron transfer takes place. So, that is oxidation numbers, and we'll talk more about those in coming lessons. So, obviously, this is an oxidation reduction reaction because there is a transfer of an electron between these two atoms. I now want to describe what's happening to sodium and chlorine using these terms, reduction and oxidation. So, just to refresh your memory, reduction here is a gain of electrons, and oxidation is a loss of electrons. So, for sodium, what's happening? Is it being reduced or is it being oxidized? Well, sodium is giving up one of its electrons, it's losing an electron, so it's being oxidized. Here's a diagram of sodium giving up that electron. Now, chlorine, on the other hand, is receiving an electron. It's gaining an electron, so chlorine is being reduced. So there's oxidation and reduction going on here. We can sort of show this oxidation and reduction with this picture that I drew, or we can describe it in words. The next thing that I want to do is I want to show you how we can write chemical equations that show oxidation and reduction. So let's start out here with chlorine. I want to write a chemical equation that shows the reduction of chlorine. So I'm going to start out with Cl here. This is neutral chlorine. It doesn't have any charge. It's this thing here. And then it receives an electron. So to write an equation for that, I'm going to write plus E minus. E minus is a symbol we use for electrons. So Cl, neutral chlorine, plus 1 electron gives me this guy right here, Cl 1 minus. So this is the equation for the reduction of chlorine, for chlorine gaining this electron here. Okay, now for sodium things are a little bit trickier for the oxidation. Let me show you why. So what I really want to write is Na minus 1 electron gives Na 1 plus. But unfortunately, I can't write this because in chemical equations, we can't use minus signs. We can only use plus signs. So I can't write the oxidation like this. Instead, I'm going to write it like this. I'm going to start out with Na here. And then I'm going to put my arrow. So Na turns into Na1 plus 1 electron. Writing the electron on this side of the equation indicates that it's being spit out, that Na is losing it. It's no longer part of the atom. So to write reduction, we put the electron on this side of the equation because it's coming together with the atom. To write oxidation, we put the electron on this side of the equation because it's getting spit out. So these are the reactions for oxidation and reduction of sodium and chloride. Now I want to talk a little bit more about these two reactions and how we can combine them to make a larger, bigger picture equation. Here's our big picture reaction for sodium and chlorine coming together to make sodium chloride. Now, this reaction here really has two processes going on within it. One of these processes is the oxidation of sodium. It starts out as 0, loses an electron, and becomes sodium 1+. And here is the equation for just the oxidation. The other process that's going on in this reaction here is the reduction of chlorine. Chlorine starts neutral at 0, it gains an electron, and it ends up as Cl1-. And here is the equation for the reduction of chlorine. Now, these two equations down here are called half reactions. They show either oxidation or reduction, and they're called half reactions because they each kind of tell half the story. You put them together, and you get the big picture reaction that shows both oxidation and reduction. So, for every oxidation-reduction reaction like this one, you can write two half reactions. One for the oxidation that takes place, and one for the reduction that takes place. Now, it's super important to keep in mind that oxidation and reduction always have to happen together. They always have to happen at the same time. Because if one atom is gaining an electron, that electron had to come from somewhere. So another atom had to give up that electron. You can see that right here. The electron here that chlorine is gaining is the same electron that sodium was releasing. So oxidation and reduction always have to happen at the same time. They always have to happen in parallel. You can't have reduction without oxidation. You can't have oxidation without reduction. So that's an introduction to oxidation reduction, or redox reactions. We learned that reduction is a gain of electrons, and oxidation is a loss of electrons. We looked at a chemical reaction where sodium and chlorine come together to make sodium chloride. Sodium starts off as neutral. It gets oxidized by losing an electron and becomes sodium 1+. Chlorine starts off as neutral. It gets reduced by gaining an electron and becomes chloride 1-. We also learned that for every big picture oxidation-reduction reaction like this, we can break it down into two half reactions, one of which shows the oxidation that's going on, and the other of which shows the reduction that's going on. Finally, we learned that oxidation and reduction always have to happen at the same time, because when one atom gains an electron and gets reduced, it had to get that electron from somewhere else, which means that another atom had to lose an electron and get oxidized.